gracias por venir. Me llamo Ricardo y soy profesor en University en Estados Unidos. Me gustaría decir todas las cosas sobre nuestro proyecto aquí en Loreto. Los seres humanos están cambiando la naturaleza. Por ejemplo, las actividades de los humanos, cambio de uso de suelo, especies invasoras, contaminación y cambio climático. Y con todos estos problemas, cambio climático es muy grande porque es un problema por todo el mundo. Por ejemplo, este gráfico aquí muestra la diferencia en la temperatura a hoy y 200 años pasados. Y ahora aquí la temperatura es 1.5 grados más grande o más alto que antes. Y hay un problema en todo el mundo con el coral y el clima. Por ejemplo, en Australia es un problema muy grande, especialmente en el norte, cerca del pueblo Townsville, cuando en este lugar hay muchos problemas con blanqueamiento de corales. En esta situación, cuando la temperatura es demasiado alta, las corales tienen un problema y adiós y la cola es blanco y blanqueamiento. Pero no sobre un problema. En otros lugares es bueno. ¿Por qué? Por ejemplo, aquí en Sydney, al sur, hay un nuevo arrecife de coral solo desde hace 15 años. Pero este arrecife es muy especial porque en este arrecife solo hay unos peces. No tiene mucha diversidad, solo unas veces. Entonces, la coral es cambiando, la distribución cambiando y es relacionado con el clima. Y es muy importante estudiar los ecosistemas porque todas las personas necesitan ecosistemas para su vida. Las personas necesitan ecosistemas saludables, por ejemplo, por comida, y aquí en Loreto por economía, especialmente los turistas y pescando. Y los lugares de naturaleza es importante por bienestar mental. Para mí, mi cabeza funcionando mejor cuando estoy muy cerca de playa y la costa, personas están más contentas aquí, pero el ecosistema es bueno, es mejor. Y no solo problemas del mundo con las corales, hay otros problemas con los otros animales también. Por ejemplo, las aves marinas. Este gráfico, aquí es años, aquí es números de aves marinas, todo el mundo. Este gráfico es de publicación de yo, de hace 10 años pasado, y en esta publicación, ¿cuántos años? 60 años pasados, hay 2 veces las aves marinas que hoy. Es menos de media de hoy. Y todo el mundo, las poblaciones de las aves marinas están disminuyendo y estas animales son indicadores de la salud de los océanos. Entonces, el cambio climático no es el único factor de estrés. Aquí en Loreto, por ejemplo, las pistas pueden perder los hábitats y a veces mostrar y molestar a los animales, pero usando los congresos sonidos es posiblemente cuantificar los problemas. Y la observación de los congresos sonidos puede proporcionar información. Y aquí, porque estudiando aquí en Loreto, pero el grupo de California es un lugar único para estudiar y es un lugar cambiando también. Un poquito menos 100 años pasado, el coral más norte en el Golfo, California, estuvo aquí. Pues ahora hay probado 2 kilómetros más al norte y un poquito menos años, 100 años pasados. Entonces, todas estas cosas es una parte de nuestra misión. Nuestra misión tiene 3 partes: educación, investigación y comunicación. La primera parte es educación. Trisha, yo, TJ y Julie enseñar a la próxima generación de estudiantes. Porque durante 9 años, Trisha y yo hemos impartido clases del campo. En esta clase los estudiantes estudian cosas técnicas y conocimientos y conservación del océano. Y un poco importante es educación marina en estado sin costas. Nuestro estado, Estados Unidos, Utah, es más de 500 kilómetros de costa. Entonces es muy importante a los estudiantes entienden sus vidas relacionadas a la costa, al mar. Cuando estudiando con nosotros, los estudiantes conductó estudios de aves con drones, cintas de transecto para cuantificar las corales, conductando estudios para medir peces y cuantificar invertebrados. Y una cosa importante sobre este proyecto: nuestros estudiantes recolectan todos los datos con nuestro proyecto. Entonces, nuestros estudiantes no solo están aprendiendo ciencia, nuestros estudiantes están haciendo ciencia. Es una cosa importante. Aquí es nuestros sitios. Hay 3 islas: Carmen, Danzante y Montserrat. Y en estas islas estuvimos colectando datos sobre los corales, peces, aves, las invertebradas, y al estudiarlos todos, obtenemos una mejor idea sobre salud general de ecosistemas, porque no solo colectando datos en una amada, colectando datos con todos. Y nuestra investigación es nuestras preguntas: ¿cómo están los pelicanos, los corales, los peces y los invertebrados? Bueno, con las poblaciones de pelicanos, ¿cuántos nidos han sido ocupados en el pasado? Este año no hay pelicanos en los nidos, pero los nidos todavía están allá. Entonces podemos ver los nidos y calcular cuántos en la zona. Poblacionamientos, comportamiento del comportamiento, qué tan grandes son las poblaciones, comportamiento hacia objetivos novedosos. Ahora hay más visitantes, más personas están visitando las islas aquí. Los complejos mercados, hay muchas más cosas novedosas, si es contento. Y con la coral, cuando estudiando el coral, hay diferencias entre las islas, hay diferencias en el lago con tiempo. Ojalá vamos a regresar en la futuro y colectar más datos. Y para la condición y salud de los corales es bueno aquí o no. Y están los peces y invertebrados, cómo ver el número de peces y invertebrados en diferentes islas. Y la última parte de nuestro proyecto es comunicación. ¿Qué pueden aprender Utah State University y Eco-Alianza y Eco unos de otros? Nuestros colegas aquí, Carlos, Michelle, tienen mucha experiencia sobre los ecosistemas. ¿Qué datos necesita en ella cómo compartir ideas y resultados. Pero hoy no es sobre hoy es sobre nuestros estudiantes. Y ahora permíteme presentar el primer grupo de estudiantes en mis amigos.
Bienvenidos, buenas tardes. Me llamo Marta y estoy acompañada aquí con mis compañeros y profesores. Les vamos a presentar nuestra investigación sobre los nidos en la isla de Montserrat. Como dijo Beth, sabemos que esta temporada no estamos complicados, pero estábamos interesados en ver cómo está la isla de nidos y cómo está. En esta presentación queremos mostrar un poco del contexto científico, cómo recolectamos los datos, los resultados y cómo los interpretamos. Para tener una mejor idea y una base de datos sobre la colonia de pícaros para monitorearlos en el grupo.
A little bit of background on the brown pelican. Has had a remarkable recovery from what was near extinction. At one point, there was about 440 successful breeding nests that were living in the wild. This species decline was mostly due to the impact of PBT, which is a pesticide that would thin the shells of the pelicans so that they would break before they reach maturity and therefore decrease successful breeding and successful reproduction. However, once DDT was banned and started being regulated and conservation efforts increased, we were able to conserve the pelicans as well as increase their numbers back to a relatively stable size. The reason why this is important is that brown pelicans are ecosystem indicators. If the pelican colonies are doing healthily, so are our marine ecosystems, and so are our fish, our shore ecosystems, just everything in between. As well as for this project, we were hoping to survey a previously unmonitored colony on the Montserrat, as we knew that there were pelicans there in the past, and we wanted to make sure we got maybe out using different methodology, just with a boat, in order to get a better estimate of population sizes as well.
Ahora, hablando de los métodos, utilizamos un drone DJI Profile y algunos programas en línea, principalmente Aerial Model y Waypoint Map. El primer paso fue generar los puntos usando una máquina de Waypoint. Estos puntos estaban organizados como pueden ver en esta foto aquí. Después subimos esos puntos al drone y a partir de ahí lo único que tuvimos que hacer fue dejar que siguiera esos puntos. Y es como se ve el drone. Y aquí le mostramos un video desde la perspectiva del drone. En realidad estaba orientado hacia abajo para ver el terreno, pero queremos enseñarle este video porque se ve muy mal y se ve muy bien. El drone capturó una foto cada 3 segundos con 70% de superposición entre imágenes para asegurar que no hubiera espacios sin cobertura. Y aquí están nosotros. Terminamos con, creo que fueron como 1000 puntos y con el programa que dije antes, aquí se ve cuando las fotos están unidas. Después todas las fotos para crear el mosaico final de la superficie. Y para contar los videos, dividimos el mosaico final en 9 secciones diferentes y asignamos cada sección entre nosotros y personas de otros grupos. Aquí es un ejemplo de un libro y cómo se ve en las fotos de drone. Y así sería cuando en cada video pusimos un punto y aquí se ve aquí un espacio. Clasificamos los videos como montones circulares de leña, normalmente sobre una metáfora rodeados de segmentos reales. Aquí se puede ver cómo estaban buscando los nidos. Aquí se ven segmentos reales y el nido, una árbol de marca. Después de muchas horas de conteo y con la ayuda de nuestros compañeros, llegamos a un total final de más o menos 6.000 nidos. Sin embargo, este total incluye nidos que no necesariamente son de este año. Hubo mucha variabilidad entre años. Algunos se veían muy degradados, mientras que otros parecían recién hechos. Había un espectro bastante amplio de condiciones.
As far as total breeding pelicans, we found, unfortunately, there were 0 viable pairs as well as any living pelicans present on the island in the colony today. However, there were a small number of colony failures that were present at this colony. That includes new nest contributions and constructions that were done this year and were attempted to breed and nesting. However, there were several abandoned eggs as well as a small rate of adult mortality with the pelicans that were still present at the site but had not successfully bred or survived. Right, so this is what our grades kind of look like, and 50% all data can be found in these 2 sectors. So 50% of all the points were there, and 95% of all of our points were found in these areas here, excluding sectors 9 and 7, which means that those 2 contain only 5% of the data. As far as this front line here, which provides the most access to the shoreline, that contained about 64.2% of all reported nest points. Row 2 contained about 20% of all reported nest points. And row 3 contained about 15.7% of all the nest points, which is indicative that location does matter when considering where to build your nest. Most of the viable habitat is located close to the coastline, as pelicans are unable to really walk that well. They prefer to just take off the cliffs. It's closer to feeding grounds, closer to roosting grounds, which means that habitat viability decreases significantly as we go away from this edge coastline here.
Así que podemos hacer unos resultados. Now that we have the number of nests and the number of pelicans, which is an unfortunate 0, we have to think about why and what that means for future data. When answering the question of why, one of the possibilities is disease on the pelicans, but given that the DBT levels have decreased since the 1900s, or the mid-1900s and up to late, that being mentioned has decreased. So that's that and other pollutants have been significantly reduced. And in the last year, 2026, there have been studies on relevant seabirds and pelicans that have shown that there is no real significant presence of diseasing birds. So we were taking that out of our hypothesis. And another option is the extreme cold, where there's periods of extreme weather, as we've seen with climate change, that have started to create irregular patterns that cause abandonment and failure of nesting sites. But these case studies have mostly been done recently in the Carolinas and Florida, in the southeast United States. And because of that different area, we have also decided to not include that in our theory, which brings us to la inanición provocada, which is starvation of the pelicans. And the pelicans, as you can see, are not dead all over the island, but due to events, los eventos climáticos, como el niño y la niña, para el niño, el agua es, la temperatura es más alta cerca de México, y un estudio de Anderson showed that between a study of 1970 to early 2000s, it showed that the pelican populations started to abandon and fail their colonies and domestic habitats when El Nino became stronger and more relevant. And the reason for that is en el agua, con una temperatura más alta, los plantos y los animales muy pequeños, y murieron y no less productive. Así los peces murieron y los aves marinos murieron o salieron. So the birds have to leave or they will die, obviously. Comida insuficiente. And this year, este año, es un super El Niño, which means that in the near future of the summer, the super El Niño is going to come through and it's going to warm the waters. But antes de ahora estaba bien y los pelícanos creyeron las habitaciones. They thought their habitats were good and nestful, so they set up their nests, and that's why we see so many nests and no pelicans, because cuando el super El Niño was coming through and is getting closer and closer, they start to realize that the fish are dying off and they have to leave. So that is basically the most reasonable explanation we have because of the super El Niño incident. And it's not really a huge surprise, but the crux of this is that food scarcity and food abundance is pretty strongly correlated to the ability to have a nesting population and to breed, and because that falls, so do the populations and the abandonment/failure of the colony occurs. So just to give ourselves some caveats and limitations de nuestros estudios. The resolution of the drone was 3 centimeters per pixel. So you zoom in, that's 3 centimeters by 3 centimeters, which is really good resolution. Pero los leyes de México, they require permits for larger drones with certain caveats as well. And in El Futuro, we could use those to get bigger drones with high resolution, more modern technology as we go. One other thing is that in the methodology that we're using, first time that we're using this, we have a lot to learn, but there's a 50-meter recommendation for where your drone is above the land of the seabirds. At the seabirds level, and you don't want to go below 50 meters where you can start to disturb them. And because of that, that decreases the resolution. You can't get as close. We obviously can't do like ground surveys. So those are some things to consider.
As far as future directions for our data and for the Isla Montserrat colony, we're hoping that this current survey data can act as a statistical baseline in order to monitor the colony as it may change. In the future, we may have breeding members of the colony that return and are successful in their breeding, and we may not. But providing this baseline data does allow for us to account for that and allows for us to monitor fully that change. We are also hoping to monitor this population success via watching these ENSO events like the El Nino, the Super El Nino that he mentioned, and see how much of an effect that has on our population. As well as we have future analysis improvements, such as being able to train computer algorithms that does land and nest classification in order to better identify each of these little locations in order to make sure that we have as little margin of error as possible. Additionally, as Deacon was mentioning, a different drone or different image quality does produce a different way to survey this colony, which does also affect pelican detection, as counting the amount of viable or past nests is very different than counting the actual amount of pelicans that are on the island. So as those presumably return to this colony, or hopefully return to this colony, that means that our detection methods and our reporting methods will have to change also. As far as key takeaways, we are hoping, well, we know that changes in habitat condition have led to colony abandonment and failure all up and down Baja and up even into the northern side of the United States, as well as future surveys can hopefully improve our data and improve our methods so that we can further understand the population dynamics and colony behaviors of the ones that reside on the monsters. And with that, I would like to introduce our hermit-crab group.
Hello, everybody. I am Aiden, this is Wyatt, and this is Ruby, and this is our study on the hermit crab feeding behavior relevance to food.
Okay, so this study is relevant because just like ground pelicans, hermit crabs are also ecosystem indicators. So, hermit crabs are key scavengers. They live in very abundant and very diverse habitats. And with that, their presence and their interactions around them really matter to the ecosystem. So, getting to observe their feeding behaviors and how they interact around novel objects is really important, especially as their ecosystems continue to change and their habitats continue to change in response to short-term and long-term consequences from human impact, as well as climate change that we've been seeing in the Baja California Surge.
So for our study, we had 3 different nights to collect data. We had 1 night on Isla Carmen and 2 nights on Isla del Infante, where we had 5 different sites to record the behavior of these hermit crabs in the presence of food, which we get out food. And we were roughly 2 meters away from the test sites with lights in order to make observations and record different behaviors. So we had a control pile of bait and a treatment pile. We had a pile of regular tuna and another pile of regular tuna, but with a novel object. In our case, we used spoons, standing upright because we didn't think they'd seen that before. It's pretty new. So we did 30-minute time intervals of observation where we took time stamps of different behaviors. And the behaviors we were interested in were their time to approach the bait piles, their approach distance, the time to touch the bait, and the time to leave the bait after touching it. And as you can see here, this is a little bit of what we saw. Imagine yourself on this beach, and this crab is going towards the spoon with the tuna. It's very vivid. It's wonderful. So we also did some analysis on Excel and R to look at this data, and we did a mixed effects model across the different nights to evaluate their latency to approach, their latency from approach to touch, and the time they spent feeding on the bait piles that we left them.
Okay, so this first graph that we have is showing all of our crab data. So here we have our 3 locations that we pulled data from. We have our first night on Carmen and our 2 nights on Monzante. Within those locations, we have our 5 sites that we collected data from. And so here you can see every single hermit crab that approached our bait. And then in the darker shaded sections, those are the crabs that actually touched our bait. So here, as you can see, our data is extremely varied. So within every single one of our 3 locations, you can see a big difference just between sites. And strangely enough, the biggest similarity is actually between Carmen Night 1 and Monsanto Night 1, even though they're completely different islands. But since there's so much variability within the actual 5 sites, our results were ultimately statistically insignificant. Here we have our first large box plot. So this one was measuring time to first approach, or latency of the first approach. And this box plot shows data from all of our experiments. And so here you can see all the hermit crabs that interact with the control group, so just tuna, and our treatment group with the novel object. As you can see, our data points are extremely scattered, right? So ultimately, the time it took to approach the control for the hermit crabs and the time it took to approach the treatment groups really were not statistically different. So yeah, there was not. Our results between the control and the treatment times were ultimately completely statistically insignificant. Here we have an experiment that's showing the same thing, so we're breaking it down into our 2 locations, so Carmen Night 1, Zonzanti Night 1, and Zonzanti Night 2. Once again, as you can see, it looks like there might be some differences between times, but ultimately our confidence intervals are so broad that, again, our latency to approach data was statistically insignificant.
So moving on to latency to touch. So the x-axis is different islands of different nights, and the y-axis is latency to touch in seconds. So the average time from the approach to touch, we did not, our results did not show any significant difference. The confidence interval is over the last 2 months for us to significant conclusions. So moving on to the time of the crab spent eating, this is our box plot based on all the traps, and it's there's not you can't see a whole lot of difference. There's points are kind of scattered all over the place, so you couldn't really draw any significant conclusions based on it. And then our last graph goes continues with the on the time of the crab spent eating, and once again, there's so much overlap between confidence intervals that we should really draw any significant conclusions, even though there's slight differences. So, in conclusion, hermit crabs don't really display any neutral behavior. They live right on the sidelines, so they're always exposed to new objects and new things. So it's hard to find something like new objects that they're not really even that they've never seen before. Hermit crab environment is at risk because the habitat will continue to be affected by human impacts and climate change. And in the future, we will continue to monitor responses and behaviors that detect changes over time. Introducing next, we have forward.
Is this on? Yes. Okay.
study benthic cover and coral health. And what's super cool about coral communities is healthy coral communities are the foundation for a lot of ecosystem processes to even begin. Things like habitat for fishes and nurseries for baby fishes to grow up in, overall food abundance. It's been shown that an increase in biodiversity, there's a lot more species present in developed coral communities than ones without. And evidence has shown that climate change may be driving coral reef development in novel locations. There was a study that was done by Ecology that dealt with this exact topic. And it's really interesting to see because if you look by map, the closest developed coral reef that's been named as coral reef is about 300 kilometers south. And there's currently no baseline data quantifying percentage benthic cover, structural complexity, or coral health here in the national park.
So, our main research questions, we have 3 of them. The first and probably the most important is, are coral reefs developing here around Laredo and around these islands? Because there's a big difference between a coral community where there's little bits of coral everywhere and an actual coral reef where they're starting to dominate the system. And we want to know if that's happening and where. Our second question is, does habitat complexity actually change when coral is introduced and starts to change the system from a rocky reef to a coral reef? And we want to know, are these coral communities / reefs healthy? And here is a graph showing expected kind of expansion of coral reefs, and Laredo is around here, the islands we went to, and we can see that they were expected to have coral reefs by 2050, and that is starting to occur.
So the way we evaluated whether this abundance of coral is actually increasing at any of these islands was by evaluating what we call benthic cover. And benthic areas are in marine ecosystems are just what is on the actual seafloor. This could be a lot of different things. And so to evaluate it, we put down this transect tape, which was 30 meters long in total. And at each 1 meter interval on that transect, we recorded right underneath the transect tape exactly what was on the seafloor at that point. In total, across all 3 islands, we were able to survey 450 total benthic cover points. So that was very exciting. Luckily, there was a lot of us here, so we were able to cover quite a bit of benthic area and get a good idea of what was going on the seafloor of these islands. Here are some pictures of some of the things that we were looking for and what we observed. By far, the most common observation we made was of turf algae, which is this little stringy yellow golden covering of this rock. We also saw a lot of hard coral, rock, sand, rubble, and occasionally we were able to find macroalgae, crustosporine algae, which is associated with coral reefs, and soft coral, which is this black coral you see here. Other benthic cover that we were looking for but didn't find in this area were sponge, seagrass, and hard corals other than branching corals. So this is our first figure. You can see on this axis is each island, and on the y-axis here we have the mean proportional abundance. Each coral on each of these, each color on each of these bars represents a different benthic cover type. So you can see here, there was actually not a ton of variation between islands. We did not find a significant difference in benthic cover type. In general, turf algae was most abundant on Montserrat and Danzante, and Carmen was the most different from the other 2 islands, where rock was the most abundant. Additionally, Carmen was the only island with soft coral as benthic cover that was recorded. Interestingly, if we put together the hard and soft corals that we saw, we actually did find that in terms of coral abundance, there was a big difference between islands. So a similar figure, we have islands on the x-axis, and instead of proportional abundance of all benthic cover types, this is just how much coral was there on average. We did find that there was a significant difference between total coral abundance at Montserrat, which is actually a really exciting result because the literature currently states that any area, marine area that has over 10% coral abundance should be managed as a coral reef. So what that means is that we are seeing reef development here in Laredo, which is really exciting.
Moving on to habitat complexity, the way we able to calculate how complex the habitats were is by doing the chain intake Lagossi method. And what that entails, we have a chain that we lay along our transect line, the same one that we laid across the seafloor. Our chain is 5 meters in length, and what we're looking for in that is to calculate the linear distance along the transect cape at each 5 meter interval. So for example, if you're taking a 5 meter chain over here, laying just flat on the seafloor, and we measure the linear distance, let's say it was also 5 meters. We would take that and we do chain length by the linear distance, get a Lagossi index value of 1.0. What that means is that the terrain is completely formed. Anything above 1.0 shows that there is some kind of structural complexity in there that is causing it to be a little rough again. On our results, we have a graph here that is plotting average Lagossi index along the y-axis. And just as a reminder, this 1.0 value means flat. As you can see, all the islands show some level of complexity, and our results were not significantly different across the sites, despite what that is saying. The differences in rocky reefs are just as structurally complex as the coral communities.
Alright, so now I'm going to talk about the coral health that we surveyed across all of the islands. And the way we did that is using the Coral Watch chart. So this was developed by the University of Queensland, and it's kind of an international standardized method for measuring coral health. And what you do is you have this coral tablet which has colors on it, and you compare it to a living coral to measure its health. And first what you do is you measure the darkest color present on that coral, and then the lightest color. And then you take the average of those two numbers, and that's the coral health. And so what we did is we did that across a whole transect, and we averaged the numbers for each coral. So what we do is, this is a 30-meter transect, and at every meter we would look across a line and see if there was a coral there. If there was, we would conduct the coral watch lines. If it was in the middle and not exactly at a meter point, it didn't get counted. And also, if there were multiple coral, we would count the closest one. So this measurement is kind of an underestimate of the overall abundance of coral, but it is a good estimate of the entire community health. Some of the ones we saw out there, the Silvora was by far the most common. This stuff was everywhere. And then this is one of the soft corals and a boulder coral. And these we only observed at Carmen. And there probably were other species out there, but since we're only counting the stuff that lines up with those meter points on the transect, we mostly observed this most common. Overall, we evaluated 207 coral, which was quite a large number, and it's indicative that this data is a good representation of the community coral health at the islands. So here are our results. On the y-axis, we have the average coral health, and on the x, we have the islands. And you can see that we have a very high health score for all the islands. 4 is quite a good number, and it's indicating that the coral is quite healthy. And the interesting thing is that Montserrat, while also being more abundant, as Max showed, is also significantly healthier than the coral at Del Monte and Carmen. The Carmen and Del Monte are not significantly different from each other, but Montserrat is better than those two. In conclusion, we found that the coral was healthy across all the islands, which is very encouraging, and it showed even greater health at Montserrat. Montserrat. There's absolutely no indication of bleaching. As you can see in those photos, all the coral was quite colorful. We didn't record really any of those super low values. And the coral community is more abundant and should be managed as the coral reef at Montserrat. This is the kind of very exciting part of this study because it shows that there are new reefs developing way farther north than has been previously documented, and Montserrat is a great example of that. The rocky reefs of downtown San Antonio are currently not classified as reefs, but we should keep an eye on them in the future as things keep changing. And then the other very interesting thing is that structural habitat complexity is consistent between rocky reefs and coral. And even though we're seeing maybe increases in fish abundance or coral, the fact that the structural habitat complexity is not changing is something that we might want to look into because it might indicate that maybe our methods aren't as fine as they should be, or that maybe complexity isn't what is causing increases in fish abundance. And now we will go to the invertebrate.
Hola, buenas tardes. Me llamo Mercy.
Me llamo Lizzie.
Soy Kate. Y nuestra presentación trata sobre los invertebrados marinos en las islas de Parque Nacional y Montserrat.
So invertebrates function as consumers of the lower growth levels, and in our study we were focusing on a couple of them. We had our urchins, and we had two different kinds of urchins. We had our herbivore urchins, and all urchins are indicators of reef system health. We had our herbivore urchins, which help to regulate algae biomass and they help to support corals. We have our predatory sea urchins, which also eat termites, sponges, and rhizomes, and they are good sources of food for fish. We have our crown thorn starfish, which is a coral consumer. We have our sea stars, which are large invertebrate predators. We have our sea cucumbers, which are predators, and they are nutrient sniffers. And we have our lobsters, which are economically important and benefit consumers. For our study, we had 3 different sites, one on Parque Nacional and Montserrat. We had 5 transit lines at each site. We also recorded the water conditions, such as the depth that we were at and the temperature. We laid out a 30-meter transit line and we swam along it, scanning 1 meter on each side, and we recorded the invertebrates that we observed by taxa. So there were sea cucumbers, sea urchins, ground sea urchins, sun stars, ground thorn sea stars, and lobsters. And we compiled all of this data and calculated taxa densities. And then we did an inverted test and a QP test in R to analyze the mean densities across the islands.
So our main purpose in looking at this invertebrate data was to try to quantify whether there was a difference in invertebrate density across the 3 islands where we surveyed. And so this figure right here, we have each island, Parque Nacional and Montserrat, on the x-axis, and then mean density, so number of invertebrates per square meter area of seafloor on the y-axis. And in our survey, we found relatively high mean densities of sea urchins, including a combined total of sea urchins, crown sea urchins specifically, and other sea urchins. Whereas the other invertebrate taxa that we looked at, lobster, crown thorn, starfish, sea cucumbers, and sea stars, did not have particularly high mean density at any of the islands. We saw these species, we saw these taxa in numbers as we were swimming across our transects, but it was typically only 1 or 2 across our entire belt survey. And so we specifically focused more on urchin density and urchin abundance. And so this figure here is set up similarly to the previous one. We have each island on the x-axis, Parque Nacional and Montserrat once again, and then mean density on the y-axis, so number of urchins per square meter. And if we look first at all sea urchins, which is the combined total of all species of urchins that we observed, we see that there is a mean density close to about 0.5 urchins per square meter at both Carmen and Danzante. And then once we get to Montserrat, that number is a lot higher. It's above 1 urchin per square meter. And when we conducted our load test in R, we found that this difference was statistically significant, that Montserrat does see a significantly higher number of sea urchins. The same trend holds if we look at crown sea urchins specifically. We saw incredibly low mean densities of crown sea urchins at Carmen and Danzante, and a much higher density of crown sea urchins at Montserrat. And once again, this trend was found to be statistically significant, which just indicates that these predatory crown sea urchins are much more abundant at Montserrat. Interestingly, if we look at other sea urchin species that are not crown sea urchins, we do not see a huge difference across islands. We have mean densities close to about 0.5 urchins per square meter for all 3 islands, and there is no statistically significant difference across all 3 sites. And so that indicates that crown sea urchins, which is the predatory species of sea urchin, is driving this overall increase of abundance in urchins that we see at Montserrat specifically. So in resumen, encontramos que los erizos de mar poblados son más abundantes en la isla de Montserrat en comparación con las islas Carmen y Danzante.
So for our interpretation, we did, again, we wanted to emphasize that we studied the urchins in 2 different groups, mainly because grazer urchins, which we saw most of the slate pencil urchins, our flower urchins, and our brown urchins here that we see. And our predatory urchin, which is our crown sea urchin, and what we found is that there was a big shift from grazer urchins to the predatory crown urchin at Montserrat. Why? Well, we think that with our results, with the significantly higher coral coverage as talked about in our previous slide, that this is linked to the significantly higher amount of crown urchins. Because predators are positively correlated with habitat diversity. And with a significantly more abundant amount of corals in Montserrat, we found that there were significantly more diversity. So there was an increased capacity for niche partitioning, more shelter for sea urchins, especially with the coral, and more complex trophic structures. So we ultimately saw the shift in a lot of our rocky reefs from grazers being the sea urchins to grazers now being the fish at Montserrat. So this further indicates that Montserrat is a distinct ecosystem compared to the other islands, and our fish group is going to tell you more about it.
Hola, muchas gracias por la presentación. La interés es la abundancia de los peces en los 3 islas en el mar.
So, starting off, why are fish important? Well, they're an important part of the ecosystem in the ocean, but also on land. They're an important link to nutrient transfer from sea to land. They get either beach themselves or go on shore or die, brings that nutrients into the soil there, or they'll get eaten by pelicans, hopefully, here soon. And they'll go upshore and they'll come back to nutrients as extra. They also provide a lot of benefits to society. So you've got economic benefits, you've got fishing, you've got tourism, that everybody comes in, you've got student groups that come in and want to study everything. And also provide a great food source. Everybody's a big fan of fish tacos out here. They also provide a good protection ecosystem that they do for themselves, so we don't have to then pay for it to rehabilitate everything. So you've got the parrotfish, the sugarfish that will eat the algae off the rocks and the corals, keeping them healthy without us having to go and do extra work. So some of our methods you've heard from our friends here. We have a couple survey sites at each island. So we started at Carmen, moved down to Montserrat and Alzante. We placed a 30-meter belt transect, so we just had a 30-meter tape, spread it out in the ocean, and then we did 2 passes along each transect. So we tried to aim for about 6 minutes, going 30 meters. We swim, 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 try not to disturb the fish, and then as you're going along, you are notating 3 different factors is what we were looking for. So, how many fish were there? What size were the fish, and where were they in the water column? So we categorized them as pelagic, so top. We've got demersal, kind of the mid-range, a little bit lower, and then benthic, the guys that are on the bottom. And then we ran this, all this student data that we collected, we ran it all through R, Excel, and we created some graphs for them. But first, pictures. So we've got 2 students, our lovely, you say these were Deacon and Martha, conducting a survey. So they were just swimming along, they notate, and then video record what they saw, so we can look at the videos later and actually look down to what species did we see. But here's a couple of ones that stood out for a couple of people's favorites. We've got the Sergeant Major, it's green colors. We've got the Fang Lenny and the Cortez Rest. So here's a couple just zoomed in locations where we've seen this already, but in Carmen, Danzante, and Montserrat, this is where GPS we located where we were exactly. So here's our results.
Yeah, so in total, we had 15 transects that we were analyzing the fish abundance data from 5 different islands. And so these are some of the general trends that we saw with this data. Starting with the overall total of fish, we can see that Montserrat had the most fish overall compared to Carmen and Danzante. Each had distinctly different abundance of the fish. We further break this down by looking at the fish abundance by type. So starting with pelagic, once again, Montserrat has the most pelagic fish abundance of the 3 islands, and both Danzante and Carmen are not statistically different from each other, but Montserrat is. Once again, we see this with the demersal fish. These are the fish that are grazing on the coral. They might be swimming close to the coral and in and out of it. And then we have the benthic fish. These are usually rather stationary when we are swimming by, hanging out in crevices, under rocks, or underneath coral, or in the sand itself. So once again, Montserrat is significantly different from Carmen, and Danzante is also kind of distinct as well. Yeah. And then total amounts we could see as the islands, it was most of Montserrat around 130 fish visible.
And then we also looked at the fish size on each island. So the y-axis shows fish size in centimeters, and then the islands listed below. And you can see that Carmen and Danzante are very similar in fish size, whereas Montserrat is quite smaller fish in their areas. And then we kind of concluded that as since Montserrat has more coral habitats, the fish species has more places to hide and like get into rather than being out in the open and being caught by predators.
It is also possible that because we are seeing a difference in the habitat type that these fish are being found in, there's an endemic color, difference in rocky reef versus the coral reef, that the difference in size and abundance of these fish could be because they're in different habitats. If there are different fish associated with the coral reef, these would be distinctly different than the fish that we see in the rocky reefs, which could explain this difference in both of the habitat class that we are seeing and the size of the fish. And I think that is everything. We want to turn the time over now to Julie to wrap us up.
¿Cómo explicaron los estudiantes? Tenemos información de 5 proyectos y hay grupos que presentaron los proyectos, pero en el campo todos ayudaron de todos. Y por eso nosotros, los estudiantes, aprendieron mucho de todos los proyectos. Hay 2 proyectos en las islas y 3 proyectos en el mar. Y los 2 proyectos en las islas son los pelicanos y cangrejos hermanitos. Y el proyecto con los pelicanos, nosotros encontramos que algunos pelicanos tienen nidos y anidaron, pero todos abandonaron los suyos. No es una problema solamente aquí, pero en muchas partes del Golfo y el Pacífico este año. Pero es saludable para niños y para niños. El otro proyecto de islas es con los cangrejos ermitaños. Y en este proyecto nosotros tenemos una línea base también por obtuvimos conteo de referencia. ¿Cuántos cangrejos están en los sitios? Y nos encontramos los comportamientos son lo mismo y los cangrejos no es importante si un objeto novedoso o no. Sin o con no es importante, es el mismo comportamiento y el mismo alimento, uso de alimento. Y esto es interesante porque la playa está cambiando y los cangrejos ermitaños están tranquilos de todos. Por los proyectos del mar, nosotros tuvimos 3 grupos, un grupo de corales, un grupo de invertebrados y un grupo de peces. Y nosotros encontramos que en todos los sitios tienen corales saludables. Pero me olvidé la palabra específico de Montserrat es importante porque los corales duros son cerca del 20% y esto es más que el marque encima del umbral de 10% y es un corales importante. Y otra cosa de Montserrat que es interesante es tiene más invertebrados de las otras islas y tiene más peces de las otras islas, los sitios en las otras islas. Pero los peces en Montserrat son un poco pequeños de las otras islas, pero está bien porque tal vez es solamente de ellos son especies más pequeñas o es un vivero para los muchos niños. Y todos juntos es posible que Montserrat es un arrecife de coral. Y por eso debería ser manejado como eso, como un arrecife. Nosotros estudiantes aprendieron mucho en este viaje. En el campo todos ayudaron todos y aprendieron mucho. Y esto, los datos que ellos tienen es importante para los próximos años. Nosotros esperamos regresar con nuevos estudiantes cada año, por muchos años en el futuro. Y este año es una línea base para estas clases en la futura. Y nosotros podemos comparar con este año cada año. Este año es nuestra primera vez por una clase y fue muy tranquilo. Por eso, tal vez no es lo mismo para Michelle. Nosotros aprendimos mucho. Y Michelle y Megan y Carlos tuvieron que responder a muchas preguntas de los profesores. Y tal vez en la próxima año no tenemos muchas preguntas, porque ahora aprendimos mucho de logístico y programación. Y es muy suave. Y nosotros aprendimos otras cosas también y un poco cosas, por ejemplo, cosas que cambiamos para los tipos de datos tener y futuros métodos de tener. Y con esto nosotros queremos agradecer a todos, a muchas gentes que ayudaron y todos los personal de Eco-Alianza especialmente y los capitanes de Happy Signatures y el personal del Parque Nacional, María de Loreto y Luis de Universidad de La Paz y ustedes. Y
pues la verdad, muchas gracias por estar en Loreto, por elegir Loreto para estar haciendo sus actividades. Todas fueron formidables, todas fueron súper interesantes. Muchas gracias por su tiempo, por su dedicación, por su esfuerzo. Y les deseo que sean unos biólogos que sigan haciendo mucha investigación, que sigan viniendo a Loreto y pues son siempre bienvenidos. Tenemos una participación del biólogo Juan Ibarría.
Archaeology, but then on the task. The ladies and PV, they do many information for this stage, and that is something very important. So what I learned when I do all this monitoring, like I said, when I say I do everything, like I go wash the fish and see who is there any likes of my partners in the bar, and he watches all the microorganisms, okay, the microorganisms that they are in the flow, and then they have to go back and see kind of salt and all that information help us to see how safety is the water or the human in Loreto. But this is going to change your mind, because in the biology, it is also important to see how is the community, the fisheries, how many fishes we have in the community, sport fishing or pesca deportiva and commercial fishing. But the other thing, with the point where you see the deployment, the waters is very different. If you see the areas where you selected the area where you're going to make deployment, it's important to see the community. That we have a very areas from Hotel Villas del Palmar, so they have the salinity. So one thing is we need to know what we have around. And all this information is you can do all together. I try to write something because I don't want to forget. But this is very important. What I learned in my information, okay, I try to do it in English. I was watching all the information when I received for a long time. But it's important to see some information when you have it that are going to help to the other group. And the other group is going to help you all together. So in this case, yo digo en español se dice se complementa. It's a complement. Okay? Something what I learned is, for example, in some areas we're going to have a lot of star. So that means that's my experience. That teach me like too many stars is not many fish. You know why? Because the star, if we have, I know many people like the star. And some people say, wow, I like esto because I'm wearing Puerto Rico, and I see a star everywhere. So that means that the numbers of the fish, the different other species, is not going to be there. So if you see this, it's very important. What kind of algae there are in those areas, they're going to show something specific for the fisheries. No? And the other thing that guys to do, all for the birds and other things, you must need to come when it's windy. When it's so windy, the pelicans come to the land. See? So you need to see what size of the island you're going to make an appointment. Because if you want to be to the other side, they're going to be so different. And the circumstance is very different. So thank you guys. I really appreciate you coming to Loreto and do all this information. Don't forget, it's very important to work together because we need to see the weather, the people start water, the people start birds, the people start fish, and all want to be together just for the environment in our community. So I'm so proud to see you here. I hope you come. You don't want to be like that money, but you're going to be stable.
¿Preguntas? ¿No? Bueno, nos cortamos la transmisión. Muchas gracias a las personas que nos siguen en Facebook y pues, muchas gracias a todos ustedes.